Hello, let's evaluate this integral I equal to integral 0 to 1 tan inverse of x square by root of 1 minus x square dx. Right here, let's consider x equal to sin t. Then dx will be cos t dt. What about the limits? If x equal to 0, that implies t will be 0. If x equal to 1, then t must be pi by 2. Right? That implies I is integral 0 to pi by 2 tan inverse of, right, x square is sin square t by root of 1 minus sin square t into dx is cos t dt. Fine. Then this is integral 0 to pi by 2 tan inverse of sin square t by root of 1 minus sin square t is cos t dt. This cos t will get cancelled, right? And finally we got I as integral 0 to pi by 2 tan inverse of sin square t dt. So here let's make this I as a function of a, right? So 0 to pi by 2 tan inverse of a sin square t dt. What we need to do is our I, that is our I value is, if a equal to 1, we'll get I, right? So let's find out first I of a. So let's try to solve this, right? If we differentiate I of a with respect to a, then this will be integral 0 to pi by 2 tan inverse x is 1 by 1 plus x square, right? This will be 1 by 1 plus a square sine power 4 t. Because we are differentiating with respect to a, sine square t will be constant. Then this will be dt, right? Here, let's consider some substitutions. Let's consider u equal to tan t. That means du equal to tan t is secant square t dt, right? This is secant square t is 1 plus tan square t. This is 1 plus tan t is u. It will be 1 plus u square dt. Fine. Then what about the limits? If t equal to 0, that means t equal to 0, u will be 0. If t equal to pi by 2, then u is infinite, right? Tan pi by 2 is infinite. Then I dash of a equal to 0 to infinity, right? Then what about this sin t? If tan t is 1, sorry, tan t is u, that is, if this angle is t, right? Tan t is opposite by adjacent, right? And this will be u by 1. Then this length will be u square plus 1. Then sin t will be u by root of u square plus 1. Here we have sin square t in the numerator, so it will be u square by u square plus 1 by 1 plus a square into sin power 4t, right? Sin power 4t is u square by u square plus 1 whole square into dt. Dt is du by 1 plus u square. So let's simplify this. This will be I dash of a equal to integral 0 to infinity, right? This will be u square by u square plus 1 whole square plus a square u power 4. As you can see, these terms 1 plus u square 1 plus u square will be u square plus 1 whole square, and this term will get cancelled, right? This will be du. So let's expand this and see integral 0 to infinity u square by, this will be u power 4, right? This will be u power 4. If you take u power 4 common here, this will be a square plus 1 into u power 4 plus 2u square plus 1 du, right? Then let's do one thing here. I dash of a equal to integral 0 to infinity multiply with 1 by u square in the numerator and denominator. Then it will be 1 by a square plus 1 into u square plus, this will be 1 by u square plus 2 into du. Fine. Let's make some simplifications here, as integral 0 to infinity, right? Here, let's write in the next step. Here, I dash of a equal to, here it is 0 to infinity. You can write the numerator as a square plus 1 u square plus 1 by u square plus 2 into du, right? Because there is a square plus 1, to write it in a certain form, I mean d of a square plus 1 terms. So let's add root of a square plus 1 into root of a square plus 1. This will be 2 times of a square plus 1, right? So let's divide it with 2 times of a square plus 1. Fine. Then add 1 by u square and subtract 1 by u square. Right? Then I dash of a will be 1 by 2 into root of a square plus 1 integral 0 to infinity. As you can see here, I mean, let's split the integral so that you can understand properly. Then this will be root a square plus 1 plus 1 by u square, right, by a square plus 1 into u square plus 1 by u square plus 2 into du plus 1 by 2 into root a square plus 1 integral 0 to infinity root of a square plus 1 minus 1 by u square by a square plus 1 u square plus 1 by u square plus 2 into du, right? This is, let this as I1, this as I2. Fine. Then let's calculate I2 first. Let's see this. This is 1 by 2 into root of a square plus 1 integral 0 to infinity. How can you write this? I mean, as you can see here, the numerator part, it can be written as d into, right, u into root of a square plus 1, because root a square plus 1 is constant, you can keep it out, then it will be du, right? Then the other part is, how about this guy? plus 1 by u, right? If it's d of 1 by u is, this will be d of u power minus 1, this will be n into x power n minus 1, this will be minus 1 by u square. So you can write it as like this, by the denominator is a square plus 1 into u square plus 1 by u square plus 2 into du. So let's try to write this denominator part in the form of the numerator, right? Then this will be 1 by 2 into root a square plus 1 integral 0 to infinity d of u into root of a square plus 1 plus 1 by u by, right? This can be written as u into root a square plus 1. How will you write this? Plus 1 by u whole square. Then this will be, uh, let's try to expand this. This denominator part here will be u square into a square plus 1, right? Plus 1 by u square plus 2 into u into 1 by u into root of a square plus 1. You will get answer. That is, you will get an extra of plus 2 into a square plus 1, right? Plus 2 into 1. That means you need to subtract this part, which is root of 2 into root a square plus 1, right? Then as you can see, it is in the form of dx by x square plus x square, right? Here a is root of 2 into 1 minus root of a square plus 1. Fine. Then this will be 1 by 2 into root of a square plus 1. This can be written as 1 by a into tan inverse x by a, right? 1 by a. A is root of 2 into, sorry, root of 2 into 1 minus root of a square plus 1, right? Into tan inverse x by a. Here x is u into root of a square plus 1 plus 1 by u by root of 2 into 1 minus root of a square plus 1. And the integral limits are 0 to infinity. So let's try to simplify this. This will be tan inverse into, when u equal to infinity, this will be 0, this will be infinity, right? Then it will be tan inverse infinity, which will be pi by 2, right? Tan inverse infinity. If u equal to 0, then this will become, this part will be 0, this will be infinity, right? In a way, this is theta pi by 2 minus pi by 2, which will be 0. That means into these constants into 0 will be 0. That means I2 is 0. Here I2 is 0. That is, this will not contribute to the I. So we need to figure out what is I of 1. We need to do in a similar way. Fine. So I is, in a way, it's I1 plus I2. Here I2 got 0. That is, I is I1. Fine. I mean, I here is I dash of A. Here I dash is I1 plus I2. Then it will be I1. So I dash of A is, so I dash of A is 1 by 2 into root a square plus 1 integral 0 to infinity root of a square plus 1 plus 1 by u square by a square plus 1 u square plus 1 by u square plus 2 du, right? Root of a square plus 1 plus 1 by u square. Fine, this is the question. Then I dash of a equal to, we'll proceed in the similar way. Root 2, sorry, 2 into root a square plus 1 integral 0 to infinity. We try to write the numerator in the form of a differential, so it will be d of, as root a square plus 1 is constant, and write just u into u square plus 1. Here you need to write as minus 1 by u, right? As differentiation of 1 by u is minus 1 by u square, then minus minus will get plus. So then this will be, try to write in the similar way. This you can write it as u into root a square plus 1 minus 1 by u whole square, right? Then uh, this will be, you will get minus 2 into root a square plus 1 as extra part. Then you need to add that term, right? 2 into 1, right, plus root of a square plus 1, right? Then this again, this is in the form of dx by x square plus a square, right? Here a is now root of 2 into 1 plus root of a square plus 1. So this is 1 by 2 into root of a square plus 1 integral, sorry, we'll write it as 1 by a, right? 1 by root of 2 into 1 plus root a square plus 1 into tan inverse of x is u into root of a square plus 1 minus 1 by u by root of a is 2 into 1 plus root of a square plus 1. Fine. Then this can be written as 1 by, it's 2 root 2 from 2 here, it's root 2 from here, root a square plus 1 to root uh, 1 plus root of a square plus 1. Right? Then what about this? Here the integration limits are, for this case, 0 to infinity. Fine. Here, as you can see, when u is infinity, this will get 0, and from this part it will be pi by 2, right? Then minus of 1 u equal to 0, this will be tan inverse of minus infinity. Then minus of infinity will be minus pi by 2, then it will get minus. So it will be finally I dash of a equal to pi by 2 root 2 into root a square plus 1 into root of 1 plus root a square plus 1. So finally we need to figure out what is a, sorry, I of a. We need to get this, we need to integrate I dash of a. What about the limits? Here, as you can see, when I of a case in the beginning, we have considered it as I of a is a function of a into sine inverse sine square tt, right? When a equal to 0, it will be tan inverse of 0, which will be 0. So then we are figuring it out from integral 0 to 1 tan inverse of x square by root of 1 minus x square, right? So what we need to do is, we know that, we know I of 0 is 0. We need to figure out I is I of 1, right? So let's try to integrate. I is integral 0 to 1 I dash of a dA. So this will be pi by 2 root 2 into integral 0 to 1, 1 by root of a square plus 1 into root of 1 plus root a square plus 1 dA. Fine. Now, so to solve this, let's make some substitutions. Let's consider this as y, that is y equal to root of 1 plus root a square plus 1, right? Then what about the limits here? If a equal to 0, then this will be y will be root of 1 plus root 1, right? This will be root 2. When a equal to 1, this will be y equal to root of 1 plus root 1 square plus 1, right? This will be root 2. Then what about dA? Here uh, y is root of 1 plus root a square plus 1, right? That implies y square minus 1 is root a square plus 1. Fine. Then this can be written as 2y dy equal to 1 by 2 root a square plus 1 into 2a dA, right? This 2 will go off. Then that is 2y dy into dA by root a square plus 1 into a. What is a here? As you can see from here, right? I mean, you can do the work here. This will be y square minus 1 equal to root of a square plus 1, right? Then a square plus 1 is y square minus 1 whole square. Then this will be a square equal to y square minus 1 whole square minus 1, right? This can be written as 1 square. Then a square is a square minus b square is a minus b into a plus b, right? Then this will be y square minus 1 plus 1 will be 0. And this will be y square minus 2. That is a is y into root y square minus 2. Then this is 2y dy into this will be 1 by pi, right? Y into root y square minus 2 is dA by root a square plus 1. This y will get cancelled. So finally, sorry, here it's dy, right? Yeah. Then this is 2a dA by root a square plus 1 is 2 into dy by root y square minus 2. So let's substitute these values here in I equal to, right? I equal to pi by 2 root 2 into integral limits are changed from root 2 to root of 1 plus root 2, root 2 to root of 1 plus root 2 into this is 1 by y into dA by root a square plus 1. This will be 1 by y into dA by root a square plus 1, right? This is dA by root a square plus 1. Then this is 2 dy by root y square minus 2. Fine. So let's do simplifications here. These two will get cancelled, right? Then this will be I is pi by root 2 into integral limits root 2 into 1 plus root 2 dy by y into root y square minus 2. Fine. Then this can be written as, let's make some substitutions here. Let's consider, right? Let's consider here y as root 2 into secant theta, right? Then dy will be root 2 secant theta tan theta. Fine. Then uh, what about the integral limits? We'll convert it first after integrating dy by y into root y square minus 2. Then we'll convert it back. Then we'll substitute the limits, right? So then let's proceed. I equal to pi by root 2 into integral dy is root 2 secant theta tan theta d theta by y is root 2 secant theta. Then what about this? Root y square minus 2 will be y square is 2 secant square theta. If you take 2 common here, this will be 1. This will be root 2 into root secant square theta minus 1, which is tan square theta. Then this will be root 2 tan theta. Root 2 tan theta, right? Then this root 2 will go off. Then secant theta tan theta, secant theta tan theta will go. Then I is pi by this root 2 and this root 2 will become pi by 2, right? Integral. Then what are the terms left? D theta. This will be pi by 2 into theta. Here our case is, as you can see from here, y is y by root 2 equal to secant theta, right? Then secant square theta equal to y square by 2, right? As we know, secant square theta minus tan square theta is equal to 1. Tan square theta is secant square theta, you can write it if you want. Secant square theta minus tan square theta is 1, right? Then tan square theta is secant square theta minus 1. This will be y square by 2 minus 1. Fine. Then theta is tan inverse of root of y square by 2 minus 1. So I is pi by 2 into tan inverse of root of y square by 2 minus 1. And now we substitute the integration limit root 2 into root of 1 plus root 2. Fine. This will be, now I is pi by 2 into tan inverse of root into y square is, this will be 1 plus root 2 by 2 minus 1 minus tan inverse of root of, this will be 2 by 2 minus 1, right? 2 by 2 will be 1, 1 minus 1 will be 0, then this will not contribute. Then this is I equal to pi by 2 into tan inverse of root of 1 by 2 plus 1 by root 2 minus 1, which can be written as pi by 2 into tan inverse of root of 1 by root 2 minus of. So finally our integral 0 to 1 tan inverse of x square by root 1 plus x square dx is pi by 2 tan inverse of 1 by root 2 minus half. So this is the final integral.